But before we start, I would give you a small introduction into the Zent-Frenger group and how it's integrated in Uponor. Zent-Frenger group was founded in 1954 and since 2012 100% part of the Uponor group. The head office and production site is nearby in the middle of Germany. We have a network, a distribution network, Europe or completely worldwide. Have sales in euro nearby 30 million and approximate 100 of employees. Till to date, I think we built more than 3.5 million square meter since the 50s, and I think it will really behind a big experience for this radiant technology. Our understanding for project work is, you can see it, piles. When we discussion from the first contact with the clients, we talk about the feasibility of a project. We talk about solution from the concept. We do the design and engineering till the installation on site, commission and handover, and finally the after-sales support on site for the project. And we go hand in hand with the architects and hand in hand also with the engineers. So, and if you're already in contact with Uponor, you know the products and the application, and as the president shows, we provide all essential installations like concrete activations, underfloor systems or plumbing systems, and the signed systems are now through Zent-Frenger implemented in the completely building solution, so we can finally build up a completely energy system, energy solution for the completely building. Beginning up from the ground, over the central LED station, up to now in the floor into each single room for the chill ceilings. Our business is to create ceilings, what kind ever, yeah. To design ceilings, special solutions, geothermal heat pumps. We do design for the ceiling system by itself, for sub-constructions, and finally also for maintenance, service. You can see some topographical pictures. This all is the range what we want to do for you, and where we want to support you for your project. We closed some international small view from international references. There was really an interesting project in Swiss called Pastatams now, and only that you get a feeling from which range that we talk about. We built in for that a project with 5,000 square meters of a seamless plasterboard system. Plasterboard in this way, because you can see the picture, it's really a very old building, and the architect is really crazy that the design of the old-fashioned ceiling, it was seamless, and so we can create the old design but the new technology behind with the railings. It was really a beautiful project. And also we realized project in the Middle East, in Mikroklimato, Whale Tower, also with 5,000 square meters of different systems of Mario Epsilon, and also other systems, and a beautiful project also that we did in Maranello, Italy, for Ferrari. You can see the range of square meter goes up and goes up. I think the biggest one that we did in the past is nearby 45,000 square meters. It was the airport in Munich, and but we are all still interested for small projects. Okay. So now let's start into the technology. Why using chill ceilings? Our mission is to create a comfortable climate. And so we have to talk about thermal comfort. You can see in the main design there, it depends on two things. It depends on the human, yes. What is he doing for action in the office, or what clothes to do his job is he wearing, what is the physical constitution of it, or the residence time in the office, and also the occupancy density at the room. This is all what depends on the human. What we can do is to part for depending on the space, on the room. Yes? And there are really big points for the air temperature, for the air moving, for the draft, for the air purity and the humidity. These blue things are all things that we can create, that we can design with engineers, with architects. Yes? There are we, as experts, responsible for. And when I search via Wikipedia to thermal comfort, I get a response that uses thermal comfort is defined state of the mind of the satisfaction expressed with the thermal environment. So, with other words, when we go with a radiant system, we are nearby relatively safe, that we have no airspeed, no draft. We are mostly nearby 90% always in the right operative room temperature. We can control the humidity and the floor temperature. And also finally, because we have always a sandwich between the register element, the aquifer element, and the panel by itself. And so we have also the issue and the topic of acoustics and the noise to control. So all in all, with a radiant system, we are talking about a thermal comfort. The radiant system by itself, I have a small funny picture. You all know the situation when you go for skiing and you sit in the sun and you always rebel. And, and it's the same if the outside, the air temperature is 10 or minus 10. Always when you're in contact and response with the sun, this is a radiation. Yes? And immediately you feel well. So if we have a look, into the DYN 1946, there is a definition of area with a thermal control in the green area. And as well, there are so many investigates and so many measurings about the dissatisfaction people based on the temperature or other things we see later in the sheets. And you can see the axle is directly in contact between the outside temperature and the room temperature. You see there's a small range between 22 and 25 degrees. That this is the thermal comfort zone. And there is the zone where we want to be. And also we know the problem of dissatisfied people based off airspeed. I think everyone knows the assistant who are working directly below airspeed or airflow, and he feels not well. Yes, and the worst case he gets lost healthy, and this is the worst case. And in this picture you can see relatively simple. If you have this DNE this function here, and if you be or stay in a neutral zone, you mostly get less than 5% dissatisfied people. And you see quite simple, if you get too warm or too cold, what's up in percent, what's, it's a bit, you see in the presentation, but you can see there grows up to 80, 70, 60% dissatisfied people if they feel unwell based on the wrong temperature. And also what we have with the temperature is also the same for the airspeed. And that means if you design your project with conventional air conditioning systems, you always run against the danger of the air draft to the people, to the employees. It's also a function of the room temperature, yeah, and the function of the airspeed. I can really see relatively simple the number of dissatisfied people. For me, the most important criteria of a thermal comfort is the mental capacity of the people if they feel well. I think for every building owner or investor should be interested to have effective employees and who feel well and can do their job very well. And so you can see also in the next function the room temperature and the mental performance from the people who are working below a system, condition system. If they feel well in the range, you earn up to 80% more capacity from the people that are working there. Out of the topic from a thermal comfort, it is also very important topic, the acoustic comfort. Always the chill ceiling includes, I mentioned, two parts, the panel myself and the aquifer meander. And when you have a look only for the panel, I think you could see also in the small sample outside at the desk, for different panels with different perforations, we earn different acoustic absorptions. I mean, you see a standard system, like the small sample outside. We have a metal sheet perforated, and inside is an acoustic fleece. And then you can see the frequency and the absorption graph. The different lines, the different color lines, depend on the high ceiling cavity. That means the space between the surface from the metal sheets and the concrete ceiling. And this is a space who depends directly from the acoustics and absorption. Depends also from the perforation, if you have big holes in it or small holes in it. Against an unperforated or non-perforated panel, you have an acoustic reflection. Yeah? You can earn any absorption. And this is the other system, for example, in our system, Variculvenum, with a high absorber system, performance system in it. And you see the different, what's up with the absorption coefficient against the standard system. So that means you can control the temperature and you can also control the acoustic in your room. As a summary of thermal and acoustic comfort, I want to show again and finally the main important topics while using radiation systems. The most thing is the temperature of the room. We have no draft. We have a directly capacity. Remember the sample with the sun and the skiing tool, and this is directly you're in contact with the energy. We can absorb the acoustics absorption, and it's also possible to integrate some cuttings in the ceiling, like a lightning sprinkler or what else is always possible. Flexible room separation, a minimum space requirements, and so finally we get in the right direction for a thermal comfort. So the products, for each design the architects want to have, we can build up a solution with radiant systems. And I always says every ceiling system could be upgraded with a radiant solution. In this range we have the chill ceiling systems. In this range we have also concrete system and additional systems, and also geothermal heat pumps. This is what Ray tell us about. But we want to have a focus more on these sealing systems. We have a part of the metal sealing, we have a part of seamless gypsum systems, and we have some products as a high performance system with a high capacity and high capacity also in the case of acoustics. So then let's start with the first product. We call it VarioCool Spectra M. M is standing for a magnet technology. The construction is, we have a meander or a snake of copper, aquifer copper, based in aluminium profiles and was fixed from support rails. Then separate we have the panel. Inside you can see the acoustic fleece, and this element we call it register element or activation or meander or different names. In a detail you can see why we call it Spectra M, the magnets drive inside. And this is the most important point, that we can really get close with the panel, with the steel panel. And take care that the energy is there, or in this way going, that we want on the surface from the panel, from the pipe over the aluminium profile onto the panel. So the big advantage from this system, Spectra M, is it could detach from the sealing panel at any time. That means also if you have built or construct a project, and 5 years later, the color of the panels depends, and get spots and scratches and what else. We can only remove the metal panel. Yes, it's quite simple to change the metal panel, and the register element, the completely hydraulic part, the installation stays at the same place. Yes, we never touch them, and this could be really a big advantage. From the power, that you have a feeling what you're talking about, based on 10 Kelvin. In the case of cooling, we have an output from nearby 100 watts a square meter. In the case of heating, we talk from more than 110 watts a square meter. And approximate this 0.55 coefficient for sound absorption. The system Spectra K is a bit different. You can see it also in the detail. We have no magnetic stripe in it. And this is the reason why we create this gluing, in German K-verkleben, technology built, because whenever you need a bit more power, it's possible to use as a panel system, not a steel panel, yes, because the magnetic. So it's possible to use an aluminium panel. And so we can earn additional nearby 10% more capacity, but only with a gluing system. We do it customized also for the Spectra M systems, in every range, with every number of rows, with every kind of pitches you need between that. You can do all customized, especially for your project. But there are also some standards with cassettes for 600 of 600, or a German standard 625, 625. This kind of sealing you can very often see in supermarkets or in schoolings or some office buildings. And from the capacity, we talk about 85 or 95 with 6 rows. And you can see the difference is not really hard to the magnetic technology. The Valium system, we call it ourselves a hybrid system. Hybrid in case that we talk from a radiant system, from an air system, from an acoustic system, and also a storage system. So I'll tell you why. When you have a look on the construction, you see the aluminium profile. It will run below side, and it is also possible at the same time to low upper side. And when the function is go upper side onto the concrete ceiling, we can store the energy into the concrete ceiling. And it's mostly effective, we do this while the night. And when we do this while the night, we can save up to 30% more energy. While the day, we stop the water circuit, and the concrete ceiling can go in touch with the room till the energy is, or the charger is empty, and then we start further with the normally way of doing radiation. Between these profiles, we use a high absorber acoustic element, and also between it's possible to use this channel as an air channel to supply the room with the air who's necessary to take care of ground airflow. And altogether, these are really big advantages that we call him a hybrid system. And also different, you can see it in this way, we use this velum system as a single element. And when we use a single element and not a closed ceiling, we can grow up with the complete capacity based off, I say, 100% of radiation part and additional 20 or 30% convection part. And this together, we can go up in a range of 120 up to 130 watts a square meter. The maximum of the length is for this element 2500, with the width 1300, and also a big point is the element height of only 30 millimeters. And this is really, for example, in Swiss and Austria, it is a bestseller because architects, they love it. It's a really small design for that. The same system, velum, you can see it here, the big point again, the design with only the height of 30 millimeters in a rectangular, or it's also possible in a 60-degree angle. Yes, it looks more lighter when I look again. I talk about the airflow. It's possible through the perforation to flow the air upward or downward. Both is possible. The air function, the high capacity, you remember we talk about the part of the radiation, additionally the convection part, and it's also fantastic for saving energy to connect the concrete mass with this system. And finally, the high performance absorber. We have some projects that we sell and use only the high absorber element without activation. It's really important thing for that. Then we go further for different possible emitter or register types. It's only a small overview. When we create, we see it later also in the sample that I have for you for doing the calculation design. When we create a register element, we start at the first point what the project is needing for capacity. This is our start point. That means we can create every kind of register. If we have 1, 2, 3, 5 pipes, or 6 pipes, or 10 pipes. We can also change the pitch between each single aluminium profile. We can use from 80 in every 10 steps up to 150. It's also possible. When you have a light inside the panel, it's also possible that we make a cutting and a big pitch in the middle so that you can use a speaker or a lamp or whatever. And finally, additional system, we call it system Quello. It's a system, we see it also later, additional L system, we can lay in between the copper pipes. And the big advantage is that you don't lose any active area when you have an airflow system in it. For every other sealing system, you can see the cuttings for, is there anyone? Yes, there is, for example, one. In this case, you lose active area. But in this case, you don't lose. Then we come to the seamless gypsum plasterboard system. We call it UNI. There is it. From the construction side, is nearby the same like the Spectra system. You see the meander, aquifer meander, was connected with a rail system. The difference is, when you remember the detail of the aluminium profile, the copper pipe was nearby on the surface from the panel, but not in the case when we use a plasterboard system. We lift up the level of the copper pipe, in that opinion, that you can use a screw, a definite screw with a height of 21 millimeters, and you can screw on every place you want. You never damage the copper pipe. But as a montage rule for our montage people is to use the definite screws of 21. And for mounting it's quite simple. You have a clip, and you clip it in the subconstruction, and only 12 clips, nearby 10 clips per square meter, and then you save, and then you fix, and the work is done. A big advantage also is when you have inactive areas, passive areas. I know competitors, when you have passive areas, yes, you have to use also this expensive aluminium profile for inactive areas, but not in this case. The height of this aluminium profile is the same height than a normal standard rail system where you can buy on every corner. From the power you see, we have less power, less capacity. We talk about nearby 70 watts square meter. The reason behind is, I think it's clear for you, gypsum is an energy break. That's it. And when we use this plasterboard, we use also especially, it calls thermoplate. It's a panel made of a higher pressure. It's also possible to use a plasterboard with graphite parts, that you get a bit more and a bit more capacity. This is all possible. Then we have seen the overview is high performance systems. This is one of them. We call it Softline 4. And the big difference is also we need now additional panel or plasterboard we have with the energy profile. We use it as the surface from the ceiling. It's made of aluminium, and you can see we talk about the radiation part and the convection part. And this, we call it, is an open ceiling. That means the convection on every part could grow up there. And so we talk finally on the capacity of, you see, capacity is more and more growing, up to 130 and 140 watts. Another system, but I have no sheet for this, we call it Opti-Y, is at the maximum at the end of the capacity with 160 watt per square meter. It's also an open system. So finally, from the products, I talk a bit about is this additional system called a Quello. It's an invisible, that's important, integratable air system for system Spectra M, and also the seamless system UNI. It contains some air profiles connected with the air box. You can put it between the register element, and from the surface you see nothing. Only the same optic like the neighbor panel. And this could be really for the ground, for the base air need, a really high benefit. The capacity, we talk from 50 to 180 cubic meters per hour. Depends also from the perforation the architect selects, and is ideal for the renovation market. And now I want to go with you into the practical side. This is a typical sample for doing design and calculation. And so we get the design from our client, and we put it into a single part. And and we can see, okay, we have to watch out for some walls, we have the dimensions, we have the axle of the rooms, and we need all information about the dimension of the lightnings, sprinklers. We have to know it, that we can create the dimension of the panel by itself and also create the subconstruction. And this is important. We decide for this sample to go with a secret panel system. You see, there is a panel system and a secret system, and the panel by itself you always or only to lie into or onto this rail system. And this is a typical view for the other rail systems with hangers, with edges, with screws, and so on. This was a cutting of this system. And also we have to define the panel by itself. And, it looks like easy and a small panel, but there are decisions behind. We have to know, is it a steel panel or an aluminium panel? Yes, and so decide if we can go further with a magnet system or a gluing system. It depends on this side. I have to watch out what is a possible dimension for that. I have to decide for the color, normally white, but from the RAL colors I know 5 or 10 different types of white. Yes, we have to define that. The perforation, where it's responsible one by one to the acoustic. We have to watch out about the edges, the corners, the cutting for lamps, sprinkler, and finally also if we have additional solution find for acoustics. So if I have made this work, this design could look like that. We can see here the secrets and the inline from the panel. Yes, we have two types in this case. And if we finally with that, we can start with the calculation, with the hydraulic calculation for activated panels. And therefore it's really important for us to know what are the flow temperature from the water. The flow temperature, the return temperature, and also the room temperature. And when we specify a system and we define a pitch, in this case 80, so we get a result from the rated power. Then we have also to look into details into the room, because I told you it's a different to earn power when you have a completely closed ceiling and you have no part of convection. When you have only the fugues between the wall and the ceiling, a small fugue of 20 millimeter, you earn up to 8% more capacity. This is important that we really search every single room. And this together with a ventilation system, when it in it, in this case it's not, but this additional ventilation system can give all additional minimal part of power, so that we have an actual power between 82 to 89, based only of this part when we open the seal in a small fugue. So then we have create in form of this the activation. This looks like this, and it's okay. We have position one type and another type. It's a bit shorter. We have types where we have to change based on the geometry from the room, and so on and so on. And now we have a look into the hydraulics. And always we say, okay, we have a room, and this room is our control loop. And this room can contain more water loops, because it's not possible that you endless connect register, 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 register. When we calculate this, we lost a pressure loss, or we're talking about a pressure loss. And the maximum of the pressure loss is nearby 25 kilopascal. And so our job is to make the hydraulic calculation in this way that every single water loop has nearby the same pressure loss. To get really stable function and a complete symmetric radiation power for that. Here you can see there are the valves and the piping are connected into the corridor. Yes, and that's all. And finally, per room, it's also important for the regulation that we have the room. We have for completely room 688 watts, have 197 kilograms per hour of ladder mass, have 12 kilopascal, and use for a main support a copper pipe of a dimension of 50 millimeters. These are the main messages for the design for our montage people and also for our supervisors on site. And then I can implement these small things, this small research, onto the completely level and also onto the completely building. So our responsibility is to promise in a sustainable solution. When we talk about comfort, health or efficiency, also the sustainability through high quality products and a high life circle, and also sustainability to protect our environment. That means all materials and all systems you see could be easily separated to recycle and save resources. As we hear about some information about leads, and this is really a main issue for these certifications. And every certification you see, and mainly the test reports, the test reports, we do it by independent institutes. This is quite important. And our competitors, they make their own test reports. So you can believe it or not. But this is for us a general rule. Every test report for every application of a system, we do it by an independent institute. So, and finally, I don't want to quit my presentation without give you a worst case. Yes, you can see it. Impression from the construction site. It's not really funny when you have a walk on the construction site and you see a picture like this, but I think it shows one more quality of our commitment. In this way, thank you for your attention, and I'm open for any questions. Or you can also, I invite you for this small information desk to give you more answers on hand with the samples.